Right, so we just want to do a little bit of a help video on how to use the calculator to solve one of these in-action quad problems. So if we have a look at this question, we've got a golf ball that's chipped. Here's the equation. Draw a sketch of the path of the ball, labelling all important information. So what do we do first? We're here with Rion and Henry. Hi, boys.
Hi, Mackies.
Henry doesn't want to speak. So the first thing that we're going to do is go to our calculator here. And where will we go?
Equation.
Excellent. So we want to go, he says equation, I say excellent, but we do actually want to go to graph. Okay, and we want to type in the equation that we had there, which I have since forgotten. So it's minus 1/5. We'll just see how good my memory is, or rather how bad it is. So minus 1/5. I think it was it said t squared, but remember on the calculator it doesn't matter about the x or the t, all it knows is that it's x, so it'll be x squared. Oh, gotta love maths type. So, gotta get up there, and it was 4x squared. What came next? Minus 38d plus 18. Can you remember that, Henry?
Yeah.
Minus 38d minus 38x plus 18. Oh, a bit sensitive. Okay, and we'll just get rid of this one. So remember, you just press F2, and yes, we want to delete. Now, if I just press graph right now, I'm going to get a cray-cray probably looking situation, because it will be set to whatever scale I was using last time. So first thing we do is I go back to Shift View Window, and I put it back to STD, which is what it was on, standard. And even here, I doubt I will get, I got some sort of graph. But if I was to draw that, I'm going to lose a lot of marks. Because if I drew this bit here, why is that bad?
It can't be negative.
Right, it can't be negative time. So what I really need to do is go to Shift View Window. The first thing I'm going to do is change that to 0. Now, I could see that on my original graph, it sort of came back down again. So 10 as my maximum would seem reasonable. If it didn't come back down again, I would increase this, make it bigger. Once you've done that, I go, yes, sometimes you will see a graph at this point, sometimes you don't, and you wouldn't panic. You would now go Shift, Zoom, Auto. And that then makes it a reasonably nice graph. I'm still not happy with that. I like to go back in, Shift View Window, and I know that, what did we do there? I know that in this case, I was about to say you can't have negative time, but because I'm in a bunker, I guess I could be below ground level, couldn't I? So it's really important to know what your X and your Y represent. Yeah. So maybe I'll just go minus 3, even that is a pretty massive bunker, very deep underground. But anyway, so now that we've got this graph, we should be able to sketch that, transfer it onto our document here, use nice axes, and sketch that graph. Okay? To answer the question, what is the maximum height that the ball reaches? We're going back to our calculator. How do I get the maximum height?
X curve, no Y count.
Don't need Y count? G-solve is your favourite button. I'm not going to go X or Y. What should I go? I want the maximum height. Have a look. And I'm going to go max. Right, so we go max, and it comes up beautifully that the maximum height will be 14.45, and it's 4.74 metres away. Yep. Now, what if I wanted to confirm that algebraically? How do I find the vertex using algebra? Sub it into what? Remember the vertex formula? Yeah, you're saying the formula. What's our formula?
Negative b over 2.
Oh, fantastic.
2a.
So it'll be x equals minus b over 2a. So remember our formula was y equals, or the height was minus a quarter, no, it was minus 1/5. 4d squared minus, I'm feeling better that my memory is a bit better than yours, Henry. Okay,
yeah.
So what is my b value in this case?
38.
38. Do I have to worry about this?
Not yet.
Would that affect my vertex? You're a bit unsure there. Let's have a think. You're going, no, maybe, yes. Remember, that's the value right out the front.
Times everything inside the bracket. No.
We could times all the way through, but remember that it's going to make the graph skinny, fat, upside down, whatever. But remember, the vertex will still always be the same with this constant out the front. So if it's pulled out, that's going to make my job a whole lot easier. So I can ignore that. So I'm going to look at minus b, so that's minus 38. So you were correct, Rion, that it's just 38 over 2 times a being 4. So 2 times 4 is 8. We could delete that from the video.
Yeah.
And we work that out. 38 divided by 8 is, lo and behold, 4.75. So if we come back to our technology, that's what we got here. It was 4.75. How could we prove algebraically that the y value is 14 point? You sub it back in. Yep. And this time, when you sub that back in, you do have to now take notice of that value out the front. So it'll be minus 1/5, 4 times 4.75 squared, and so on. Put it in your count and done. So you got to read the question. If it doesn't ask you to show it algebraically, you don't need to use this formula. But if it does, then of course, please do so. So what's our next question? How far away does the ball land from where it was struck? So let's go back and look at our graph. Well, it was struck here, wasn't it? So how do I find these points?
G-solve.
It's G-solve again. They're x-intercepts. Fantastic. I go to G-solve, but I see no x-intercept there. What's the value? What's the word that we use for x-intercept? The root. So we press that, and we struck the ball 0.5 meters away from, I don't know, where we stood initially. And so at 0.5 it got struck, and over we go to 9 meters. So obviously 8.5 meters away.
Yeah.
Okay? Does that make sense? So it's just about using our calculator. How high is the ball after 3 seconds? What will we do there? Y calc and X calc. So how high is the ball after 3? Now that was a little bit naughty of me because that's a bad question. It should have been after 3 meters because D is not time. Okay, so we go G-solve, and to get our Y and X calc, we push that button and it's a Y calc. So we pop in 3 and there she blows. Okay. If I had said how far away from the ball was struck, when was it 12 meters? Right, you can see that it's going to be here, but it's also going to be another value there. So you could move it across, but we're doing a Y calc in this case, so we don't have to do that. Let's go back. What's our last question? How far away is the ball from when it was originally struck when it is a height of 5 meters? So we go back to our calculator. It's now a height of 5 meters, so that's your Y value. So it's your Y value, so you're wanting to do an X calc, correct? So G-solve, more, we're doing an X calc. We pop in the 5, and this is what we were just talking about before, that we've got one value here, but we can see clearly there's going to be another value over the other side. So push my arrow and go like that. I have to say I prefer to actually put in that horizontal line of Y equals 5. I can then draw that, and I can now go G-solve intersection. So it's up to you whether you want to see that or not. And that's how far away it will be. So it's all about getting to know your calculator and knowing when it's a Y calc and when it's an X calc. That's about it. We can leave that one there. Does that help?
Yeah. Is that on the question?
Yeah, probably, yeah.